Right, great. So now we have progressed to the stage where we are able to understand the concept behind Panda's design of the two new objects, data frames and series. And then we focus more of our discussion on data frames because this is the primary structure or model that we can use to represent real world data and content. And then we learn of ways to extract out um, contents by the column labels, the index labels, and also by positions. And then we have means to also extract arbitrary positions and cells. And we also learned how to perform some basic actions like replacement, fill up the nans, and also append columns and rows, and delete columns and rows. So we are very versatile already. In what follows, we're going to learn how to make larger data frames. We're going to compose larger data frames from data frames. Yep. So we're going to like basically treat a data frame as a Lego block and then make larger objects out of them. There are three new functions we like to pick up on in this video session. They are concat, all right, doesn't respond. Concat, merge, and join. Concat, merge, and join. Just very top level for now. Concat works at data frame level and basically just really literally block positions the data frame around another data frame. And it can be also 3 or 4 data frames concatenated, just force positioned together. Don't care about the column labels duplicating each other, row labels, index labels, having duplicated values and labels. Don't care, just force position. Okay, and very quickly at top level again, just a quick understanding. Merge looks at the content value. So merge is a very column operation. Merge performs mostly column-based kind of merging. So what it does is it's actually dependent on the content. So we are merge is going to look at the cell values. So it's a little bit different. And then it decides how to position it or insert nans accordingly. Now we'll talk more about that. And finally, join also is a column-based operation. Remember earlier on, I kind of warned you already. Pandas, even though it has a two-dimensional data frame kind of table, it actually has certain asymmetrical treatment between columns and rows. So it kind of prefers columns, or it more expeditiously, more efficiently handles columns and has more and offers more liberty to deal with columns. So here we see merge looking at the contents and join looking at the content of the columns, but the content needs to be sort of pushed to the index first if you want the content to go to the index, right? So it looks at the index labels and then combines the data frames together based on the content in the index labels. Index labels, right? So it's a column operations, but it kind of looks at the index values. And we have a way to also make the content of the column as a index, and therefore when join looks at the index, it's also indirectly looking at the column. So we'll discuss more in a while. Okay, so three functions that we need to get good with, because then we are able to assemble large data frames. Now, in real life, why would we do that? Why would we concatenate data frames? Sometimes it is because one data frame is from before, one data frame is from later on, and one data frame is from after, something like that. So you have a time series of data frames because you're capturing multiple sensory information or records or measurements. So when you have that and you really want, because each data frame for that day of measurements in terms of hours or minutes already is a lot, so it's captured as data frame. But when you need to process, like find the average or standard deviation, you really want a huge data frame. Yeah, so you are going to have to combine, but we don't say combine, we concatenate all the data frames together. Hmm? So for obvious lack of space, I'm just going to use two data frames, but the concat operation in pandas can take 10, 20, 50 data frames just by listing them in a list. Next thing you need to notice is the concat. Up until so far, our discussion on replace, fill any, append, drop, and all these are based on the data frame dot, right? So we have a variable that is a data frame, but this is a PD operation. So at the topmost pandas level, concat basically is like creating a new data frame, except the data, the many sets of data, they are from existing data frames, right? So instead of saying PD dot data frame supplying data frames, that's not allowed. Multiple data frames, that's not allowed. We use PD dot concat. So think of concat as another way to create new data frame by taking existing data frames as basic building blocks. Okay, so that's a fine point to remember. So don't put df dot concat, but pd dot concat. So we first create two smallish data frames. Later on in the lab, we'll do this. And then try to concatenate. So here I have beautiful pictures and colorful labels to show you what are the effects first. Now, of course, nothing beats real experience on creating them. We'll come to that in a while. All right. So here, stay with me in the classroom here. We have the two DF1 and DF2 data frames, smallish, and purposely different shape. All right, having different shapes. Here, the columns are intentionally created so that one of them, is common, but the rest are not the same. And likewise for the indices. And now, many different combinations can happen, but let's stick with this for now. Now, here, what happens if we say pd.concat, have a list of df1, df2 in that order. So df1 first, then df2. Okay. If we reorientate it, we will get a differently uh, uh, con differently set content from the data because the sequence matter. So df1, df2, axis equals to 1. What does that mean? Axis is panda's way of saying, do you want me to look at a row or you look at column? Uh, so axis equals to 1 means, as I kind of annotate here, to paste additional data frames sideways. Now, whether you call that extension of the rows or that's column-wise extension, it's subjective. So best is to just internalize your understanding. But the pandas way of saying it is axis equals to 1 means df1 and then to the right-hand side. So by columns, all right. So to the right of it, stick on with df2 and df3 and df4 and df1. So when we say axis equals to 1, BD will be from DF1 and then CD will be from DF2. Just hard force them together like that. And here, what's going to happen is we see that we have 2278, right? So we're going to put 2278 because they are going to be aligned 0011 like that. And when we concat like that, we are using axis equals to 1. What happens if we add something else like df3? We don't put any axis equals to 1. Well, then it's a little bit like dot append, but not the same. Not the same, right? So it's a little bit like dot append. So pd.concat df1, df2, a bit like df4 here, but without specifying axis equals to 1 means axis equals to 0. But what does that mean? Axis equals to 0 just in this case means the next, how should I call it? the next set of data, that is this 2278 here, is going to be concatenated downward. So the next listed data frame is to be sort of plonked below as additional rows. Okay, so the basic concept is without specifying axis, that's axis equals to 0. That means it's row-wise addition. Axis equals to 1, column-wise pasting. So row-wise, column-wise. Now, row-wise pasting also has a little bit of trickery here because let's look at the outcome. When we put rows, how come we don't see C and D? Well, D is there, right? So what concat does is that it says, oh, well, D is the same, all right? And it's not going to sort of find common values like 2288, so I skip them. It's not. It's going to actually put them in, like forcefully put them in, except the common column labels like D here is being aligned. Yeah. Notice that because of the D being the rightmost, and the D here is supposed to be aligned with the D, and then C cannot be stuck under B, right? Because that's got no meaning. So C has to be in the third column, like here. So ends up that we have 28, then 27. So it's kind of like the column is being swapped forcefully. Yeah. But notice that the basic operation is still that 2278 never has any content being deleted. It's the whole block that is being put in. But column wise, they have to swap a bit to adhere to the column label positioning. So 28 comes from the 28 here. Then we have 27 and the 27. So a new column C is created in the resulting concat when we plonk the second DF below. And therefore, for the upper rows, nothing is there. And the way we say nothing cannot be a 0 because obviously if you're averaging marks, then 0 will drastically reduce the marks. It's much better to indicate with a sentinel. Sentinel means it's a proper value that is meaning nothing. Right, so 0 is a proper value that is meaning no value, and that is not good because 0 in your ATM account means no money. That's different from saying error. That means you may have money, but ATM is having some error. Please check, something like that. So it's different meaning totally. So the right thing is pandas will fill in NAN, right? So the I didn't have space, so I just use capital N, but it is NAN. So the NANs are filled here where there's a void, and there's also a small gap here because there are no defined values for B contributed by DF2. And so these are also filled in as N. Okay, let's try again. Now, actually, when we don't specify anything, it is everything and everything. You see that no column and row is being left out. Everything is tried to pushed in as much as possible where it makes sense. So that is for what we think about as a outer kind of join. Now, what if we say PD concat, everything is the same, and then inner join, inner join. So what does that mean? Inner join.